Good morning, everybody. Today is Sunday, April 19th, and this is a short video to help you with the virtual lab this week. The lab is the same for both engineering surveying and practical surveying. So I'm using mostly the engineering surveying web page, Moodle page, but it's exactly the same for our class in practical surveying as well. So the topic this week is Global Positioning System, which is abbreviated GPS. And the first thing is I want you to see that there are 3 vlogs that you need to watch in order to understand these ideas. In times past, in a typical year, we have a former student, currently a land surveyor, from Engineering Associates come and do a demonstration for us because we don't actually own a GPS unit. So we have a demonstration, and the nature of the demonstration is way back when Engineering Associates has been doing this for us for a really long time. And a long time ago, back in about 20 years ago, they actually laid in a survey course for us out behind the Math and Science building. So this is in your lab write-up, and this is what we're going to be working with. But you can see that it was done by Engineering Associates, and you can see that there is an assumed north direction. And then there are a series of survey points that Engineering Associates laid in for us. So there are 2 pages to the original document. There's this, which is the math piece, and then this, which is the work they did the day that they were out and actually laid in the course. So you can see that the Math and Science building, which they refer to as engineering building, is right here, and that we have 2 survey points, one labeled 1036 and one labeled 1037, that are identified from their location based upon their relationship to the Math and Science building. Then there are other points, 1039, 1038, and so forth, one of which is up here in the median. So in other words, 7th Street would run right here, and then there's a median and a grassy area, a boulevard in between, in the middle of 7th Street, and point 1000 is in that median or island. So what we're going to do this week, if we had the surveyor come out and work with us, we would have found these caps using GPS. And one of the things that's really neat about GPS is it is so much easier to find these points using GPS than it is using a total station. Now, the data, and you are going to learn this when you are working with when you're watching the vlogs and when you're doing the homework and reading the textbook, but the data that's returned to a GPS is in what are called coordinates, and that data is right here. So this is what we're going to be working with in the lab today. The name of the point, 1000, for example, the first piece of data, this huge piece of data, 1499997.474, is the feet in an assumed north direction from some arbitrary point, not on this survey point, not on this survey course, but somewhere else. The next is the east coordinate, or relative or assumed east coordinate, 470.126.416, from once again, some relative or arbitrary point off the survey course. The third piece of data, 4499.950, is the elevation above mean sea level of that point. And the last column tells you a description, whether it's a spike, a brass cap, an aluminum cap, or it could be something else as well. So one of the things that we do, these are referred to as coordinate geometries. This number is called a northing. This number is called an easting. And if you're looking at the difference in northings or the difference in eastings, that is called latitude and departure. We can use that data to find the distance and the direction between 2 points, which is what we're going to be doing in this lab. So if we go to the last page of the lab, I did an example for you between 2 points. First of all, we'll go up here, and it says the procedure is to watch, and I do a calculation of the distance and relative direction between point 1039 and 1005. Then I ask you to do the same thing for 2 points for your lab procedure between 1010 and 1006. Now, an important thing to notice about this is I'm asking you for the distance and the relative direction between the points. That means that if one point is southwest to the other, that the other point is northeast to the other. So you just have to keep that in mind. I didn't really ask specifically to go from one point to the next, but I'm assuming that you do one or the other. So if you go to the last page of this lab write-up, what you'll see is an example of the calculation that I did for the 2 points that I chose. Now, the data that I got is from this set of coordinate data right here that Engineering Associates produced for us when they laid in the survey course. So down here on the bottom page of your lab is the data that I transcribed from that section for points 1005 and 1039. The first point, I've sort of changed the direction. This would have been the last column in their data set. I've put it as the second column. So I have the name of the point, the description, then I have the northing, or in other words, how many feet that point is north of some arbitrarily chosen point, and then the easting, or how many feet east the point will be. Now, the other thing that I just really need to emphasize is the north is an assumed north. So if you look at our data and you look at the north arrow on the data, this is the assumed direction of north. And since you can see that the median, 0.106, 1006 is up here, 1005 is up here, and we can see from our data set that 0.1000 is in the median, and 135 is below the median. This would be sort of south, but we're assuming north to be perfectly parallel with Division Street. That is not necessarily true, but if you don't know exactly where true north is, if you do a survey set from an assumed north meridian, then you could rotate it later on, and all of your relative locations will rotate perfectly into a true north, true east coordinate rows, compass rows. All right, so continuing with that idea then, what I find by looking at the points is that point 139 is southwest of 1005, which means that 1005 would be northeast of 1039. If I go back and I take a look at the data, you can see where I came up with that idea. Here is 1039, and here is 1005. So 1005 is clearly north, or is in the assumed north direction, and it's slightly to the east. So this point is southwest of this point is northeast of this point. So as long as you don't get those two things mixed up, make one north and one west, for example, or one south and one east. Okay, so as long as you keep that in mind. All right, so the first thing I want to find in my latitude and departure, in other words, the difference between my northings. Since these are in feet, I can just subtract them to find the difference in north between the 2 points, and I come up with 471.878 feet. It's negative because a negative north is south, just like a negative east is west. So since this point is southwest, my northing is going to be negative and my easting is going to be negative. But I find them in the same way. I write my northings, I write my eastings, I subtract them, get my latitude and departure, and I've got those two distances. Now, how would I find the absolute distance? Since north and east are perpendicular to each other, I can use the theorem of Pythagoras, and I can take that, this should have a delta in front of it and a delta, okay? So the change in my northing, which is 471.878, negative, and I'm going to change my easting, negative 62.148, square each of those individual values, add them together, take the square root of that sum, and I get 475.95 feet. That means that those 2 points, 1005 and 1039, are 475.95 feet from each other. Now, the direction that you would take if you were at, say, point 1039 and you wanted to go to 1005, you know that you would need to walk 475.95 feet. However, what would be your direction based on that relative north. Well, once again, you can lay out a little trig problem here. We know that from 1039 to 1005, we have to move 62.148 feet to the east, and we would have to move 471.878 feet to the north, and that the total distance would be 475.85 feet. Okay, well, based on this triangle, I have a right triangle, so I can see that the tangent of this angle right here is going to be the opposite length, 471.878, over the adjacent length, 62.148. So if I take the arctangent of that, or the inverse tangent, I'll find the angle from here to here. Since I like to reference directions from the compass rose or from north, I then want to find the angle from the north arrow. That's actually from the easting, the relative east. So since north and east are 90 degrees apart, I can subtract that from 90 degrees, and I find that this angle, which is really the angle I'm interested in, is 7.5 degrees. So what that means is, in order to walk from 1039 to 1005, I need to walk 475.95 feet, and the direction I would walk would be 7.5 degrees, 7.5 degrees to the east of the assumed north direction. All right, so this is what you are going to do, this exact same calculation, only between two different points. I've used 1005, or 1005 and 1039. I'd like you to do the same thing with 1010 and 1006. So the data for them is right here. Here's the data for 1010. Here's the data for 1006. Same thing, northing, easting, elevation, description. So if you write out your data like this, please do it in your field book. And then when you submit a picture of your field book to me. So that's it for today, ladies and gentlemen. If you have any other questions, please let me know. I am working from home again still, and I will look forward to hearing from you. And also have a great week. Ask me if you have any questions. And if we have not set up a time to advise you, or if you've not set up a time with your advisor to get classes for either summer or fall, please do so. And whether or not I'm your advisor, I would be very happy to work with you if you would like me to. Take care.